Java Introduction by James Gowdy. I want to give a little bit of history about Java before we get actually into the programming, and then some of the basics before we get into our first program. So first off, Java was created by James Gosling and his team of developers back in 1995, and it was originally created to run applets or small programs on web pages. And this was the time here when the web was just starting to explode. The Pentium processor was just released there in 1993, and the home PCs were just now starting to take hold and be part of the computing culture. So it was started off by Sun Microsystems and then bought out by Oracle in 2010. Program features. Let's talk about some of the program features for Java. First off, it's object-oriented programming. Okay, this means that it uses objects and modules and classes to organize how programs are put together. And we're going to talk more about that later in the semester. Next thing I want to talk about here for program features is it's platform neutral, okay? Meaning that any device that can run a Java virtual machine can run your Java program, okay? So you write the program, your source code once, and then you can run that on many platforms. So it's one source code, lots of different platforms. So if you're running a Mac, if you're running a PC, if you're running a smartphone, you're running any other type of main device on it that can run a Java virtual machine, you can run your Java programs. And what happens is we take our source code, we type in, we code, that gets formatted into bytecode, and the bytecode is the actual code that gets run on the virtual machine. Next thing we want to talk about here is memory allocations and deallocations. Java takes care of that automatically for us. So if you're coming from a C and C++ environment, okay, you had to allocate and deallocate the memory manually. Well, Java takes care of that. So that's a big deal on that. So it keeps our resources running very efficiently. Also, I want to point out here, Java does not include pointers. So if you're coming from the C and C++ side of the house up there, you're not going to find any pointers in Java. There's other ways of doing it in there, and we'll talk about that later in the semester. And one other point here is Java includes only single inheritance. This goes back to the object-oriented type of programming on here. But it means up here we can only have one source of inheritance. So if you're coming from a C and C++ side of the house, you're going to find out you only have single inheritance on the Java side of the house. IDE, Integrated Development Environments. Let's talk about these. There are two major players. There's Eclipse and NetBeans. And what these IDEs do is they give us a framework or shell in which we can write our code. And it will check our syntax. It will check to see if we have the proper libraries loaded. So it really does a good thing on expediting and making our code writing very efficient. Eclipse was the first to the market. It's open source. It uses lots of plugins. And hence, therefore, it has a little more larger market share. On the other hand, NetBeans is sponsored by Oracle, and it's used by a lot of corporations, and it sort of matches the Visual Studio look and feel. So if you're coming from the Microsoft side of the house, you're going to feel real comfortable moving into NetBeans. It's often asked, do I need an IDE to code? No, you can write everything in Notepad if you wanted to. However, you're going to find out that Notepad will not check your syntax, not check your library connections, and will not find a lot of errors. So using an IDE makes your coding very efficient, and it will expedite your code writing. Variables. Variables allow us to store single chunks of data. And sometimes when we are creating variables, sometimes you'll see them referred to as declaring a variable. So I have a couple of examples listed here. So it's important that we tell Java what type of data we're storing, and we have to give it a name. And so, like for example here, we have int and age. We have string and first name. We have bool and breathing. So that'd be sort of a fun one to see if maybe you're playing a game and whether or not your character is breathing. A boolean is true or false. A string stores alphanumerics, and an int stores whole numbers. We'll get more into this in just a little bit. We can also create multiple variables at one time. So if you look here, we have string and then we have first name, last name. So we're creating two variables on one line of code. We can also do like multiple ones here for numbers. So here we have a data type called double, and we're creating the variable num1, num2, and answer. So we can create multiple variables at one time on one line, or we can create them one variable at a time. Variable names. Variable names have some very specific criteria on what we can actually name them. So first off, they can start with a letter, an underscore, or a dollar sign. Okay, but they cannot start with a number. Also, we do not want to put any spaces in our variable names. They have to be all together. All the variable names are case sensitive. So if you look down here at the example here, I have f name, and I have got it spelled out several different ways. And you notice here the first way is all lowercase. And then we have the one with the F as the capitalized, and then here the next one we have the N is capitalized, and then you can see the other two examples here. Java will treat all 5 of those as different variables. Okay, so it's case sensitive. As a matter of fact, all of Java is case sensitive. So you really have to watch your typing skills and make sure you watch your cap keys on that. Data types. Java has 8 primitive data types, and like I said before on here, we have to tell Java exactly what type of data we're dealing with. So we basically falls into a couple different categories. We've got 2 number categories, integer and real/floating, and then we have Boolean, chars, and strings. Okay, so let's talk about the numbers here. Integers are whole numbers, okay, no decimals. And then we have real and floating point. So they do have the decimal point. Okay. Now this is important for 2 reasons on that. First off, integers take smaller space and take less computing power than the real floating point. And then the second part of that is if we're dealing with math operations, okay, an integer math is different than real and floating point. So for instance, if I had 1 divided by 3 and it's integer math, okay, the answer would be 0. If we're using a real or floating point data type, then we would have the 0.33333 repeating. Okay, so it's real important to be cognizant of what type of data we're dealing with. Now let's just sort of look at here, and you can sort of see the chart here on what's happening here. So we sort of look at our data and we say, hey, wait a minute. I'm going to have values that's going to be no larger than 32,767. Okay, so if I've got values that are going to be less within that range, then I can use the short data type. If I'm using a value here that's going to be greater than 32,000 and less than or equal to approximately 2 billion, then I'll probably want to use the int data type. Or if I got something greater than 2 billion, then we're probably going to need to use the long. Okay. Now if you look here, I have listed upon the chart here the different sizes, 8 bits, 16 bits, 32 bits, 64 bits. Okay, so a bit is a 1. So for a short, that's 16 ones and zeros. Okay, if we go down to an int, there's 32. So we see that that number's twice the size. And that's what gives us our max values for the different data types. Now if we look down in the real and floating points, so if we're dealing stuff with decimal points, then we have 2 options. We have the float and we have the double. So basically, if we're dealing with a number that's up to 3.4 times 10 to the 38th power, we can use a float. If we're going to do something even larger, okay, maybe we're working for something for NASA, and we'd have to have something really huge on that, then we can use a double, and we're basically looking at 1.7 times 10 to the 308th power. That's 308 zeros. Lots of places. I just want to point out too on here that if we're dealing with precise decimals, okay, like we're doing stuff with currency, or we're doing stuff with extremely accurate measurements on the decimal side of the house, on the right hand side of the decimal, then we want to use the Java math.big decimal library. Okay, so if we need to do precise decimals, we want to use the big decimal library because that will take account of the rounding, and I'll make sure our rounding accuracy is very accurate. Now there's a couple other data types we need to deal with. Boolean. Okay, Boolean there is true and false. Okay, so we're checking whether something is true or false. Chars, these are individual letters or characters. And then now we have string. Now string, it's treated like a primitive data type, but it's actually a class, meaning there's operations that can go with this. But for a string, at this moment in time, it can hold alphanumerics, and it can hold up to about 2 billion characters. So if you wanted to store one of the works of Shakespeare, you could do it in one string variable. Chars, one other note on that, they are usually width specific. So if we set up a char to only hold 2 characters, it will always hold 2 characters. Or if we tell a char to hold 10 characters, and we're only putting 5 characters in it, it will still hold the other 5 space on it. Where strings are variable, so it will only take up as much space as it needs. So those are the primitive data types in Java. Variable examples. I've listed here some examples here of how we declare variables in Java. And if we look up here, we have the one called int age, and then we also have int age equals 0. So the int age equals 0, here we're setting that initial value to 0. We've got a couple here with the floats. We have a float in salary, and then we have one here where float salary equals 100,000. So in the second example of that one, we're actually setting the initial value to 100,000. Boolean, we can actually set that to true or false. Those are the only 2 values we can put in for that. Chars, we have an example of a char here for a middle initial. And I want to point out there that chars usually are enclosed by single quotes. And if we look down here at strings, strings are enclosed usually by double quotes. So if we are dealing with lots of words and text up here, we're going to use a string and we're going to enclose those in a double quote. Constant variables. Constant variables are variables that we're going to set in which the values will not change. So there are times up here we want to set that variable value, and we don't want to have any other parts of the program to be able to change that value. And for example, that could be like pi 3.14 or a conversion factor. We don't want those to change. So in order to designate that, we're going to use the word final in front of our variable name. And the convention is to make that variable name in all caps. Constant examples. So here I've got a couple of constant examples to show you. If we look up here, we have final float pi equals 3.14. So the final is going to set the variable name. We have our data type float, and then we have our variable name pi, and then here's our initial value. We can look down here. We have another one here, final float H2O boil. So this is the boiling point of water equal to 212. So final setting the value, we have our data type followed by our variable name in caps. Can you use other variable names in here besides float? You can. You can use any of the data types on there. You're just not limited to float. We're going to talk about enumeration a little later on here, but enumeration is using a variable name instead of a value. And for example, if we were coding a game in which north was 10 units north and south was 20 units and east was 30 units and west was 40 units, instead of thinking out, hey, which direction to go on this, we can actually do something like here, direction equals east. So that's sort of an example of using enumeration. We'll talk more about it later in the course, but here's how couple examples on how we can use the word final and lock in our values. Commenting our code is very important. We need to make notes of what we're using, the type of logic we're using, any special instructions, any special algorithms. So when we look at that code a year from now or 2 years from now, we know what's going on logic-wise. Or if we're working with multiple programmers on this, we need to comment our code so they have an understanding of our type of thinking and our type of logic and our type of algorithms that we're using to write the program. Now we have a couple different styles on how we can comment our code. We can use the // and if we use the double slash, we can comment on a line. So you can see here an example here of / James Gowdy / assignment 1 / January 23, 1996. Or we can do multiple lines. So we can do like /*, and then we can write out paragraphs if we want to, or multiple lines, ending it with a */. Now, Java has this thing called Java Doc, which allows, it's a formal package to pull out the documentation and to package it in a nice, neat package. So if you're going to use Java Doc, you're going to notate those notes by using /*, and you're going to end your note with //, just like the previous example here with the multiple lines. The only thing you're going to use different is you're going to start your comment off with 2 stars instead of 1. I have a couple examples of here where you can have a line of code and have the comment follow the code, or we can put our comment above or below our code. So here's a couple of different examples on how we comment and whether or not we need to use // or if we want to use the /*. Character escape codes are used within strings. So within that string itself, if we need to add a new line, put a tab, or maybe a single quote or a double quote, we can use character escape codes. So I've got a few of them listed here, /n, /t, // quote. So if you need to do any of these functions within a string, we use a character escape code. A lot of times when we code, we need to increase a variable by 1 or decrease the value of a variable by 1. So there's a couple of little shortcuts here. To increment, meaning to add 1, we can do like the variable name ++. So we can do like x++ or y++, and that will take the variable up by 1. Or if we need to subtract by 1, we can do like x minus minus or y minus minus. That's all there is to it. So a lot of times they're used in loops where we need to count, and this is an easy shorthand way of doing it. The other way you would do the very same thing if you want to write it out longer, it would be x equals x plus 1 or x equals x minus 1. So the x++ is a lot quicker, and it's a nice shorthand way of incrementing and decrementing our variables. I just wanted to give you a quick list here of the operators for the addition, subtraction, divide, and modulus. If you're not familiar with modulus, basically it's used in integer math, and it returns the remainder. I want to show you here the comparative operators, and basically we use to check the comparative operators to see if something is true. And I want to point out just a couple things here. Equals, if we want to compare equality, it's equal equals. Okay, you'll notice on the slide here it's not x equal y. Okay, that will always be true because we're assigning the value of y to x every time, and that will always be true. So if we need to check equality, it's going to be x equal y, not x equal y. So watch that, that'll catch you. Not equal, if you're not familiar with that, is exclamation point equal. And then the rest of them look pretty much like you've seen in math. I do want to point out to you here, if you're using the greater than or less than equal signs, so if we're doing greater than or equal to or less than or equal to, there is no space between the signs. So it's greater than equal with no space, or greater than equal and no space. I just want to throw out a couple of the logical operators here, the two common ones, and and or. There's a couple more out there, but I just want to talk about and or for right now. And basically we either see them as one and, or the double and sign, or the or is, the logical or is designated as a pipe, the vertical up and down, or a double pipe. Okay, so what's the rub? What's the difference? If the double and or the double pipe is used, when it reads that expression from left to right, if that first expression is false, then it's not going to look at the right hand side on that. So sometimes it's called short circuiting. Sometimes it can have some nuances in your programming on that. But that's the difference on that. We're going to see these in action later on when we get into iteration and loops. I just want to talk a little bit here about the order of operations, and as you can see here I've got them sort of listed from top down. So they're going to do the increment and decrement first, followed by our arithmetic operations, then our comparison, logical operators, and assignment expressions. So it just follows the same logic that you've seen in math. Concatenation is the action of putting two or more strings together. So for instance here, you can see here we're putting Bubba in the F-name variable, Smith in the L-name variable, and so we're going to actually build a full name. So we're going to do F-name plus quote space quotes L-name. So the quote space quote, that's actually going to put the space between the name. If we needed to separate them with a dash, it would be quote dash quote. Or if we needed to separate them with a comma, it would be quote comma quote. So concatenation using the plus sign, and this is how we build strings in Java. This concludes our brief introduction to Java.